OSPF LSA types and areas. Welcome to the channel. Please consider subscribing. I produce videos daily covering a wide variety of cloud topics with focus on networking. Also, hit the bell icon to get notified of new videos. Today we are tackling Open Shortest Path First Link State Advertisement Types and Area Types, which is one of the most commonly examined topics in CCNA, CCNP, and CCIE. Open Shortest Path First does not simply flood a single type of routing information across the entire network. Instead, it uses several distinct link state advertisement types, each with a specific scope and purpose, and it restricts which link state advertisement types can enter certain area types. Understanding both what each link state advertisement carries and where it is allowed to travel is essential for designing and troubleshooting Open Shortest Path First networks. By the end of this series, you will have a mnemonic for the 6 LSA types used in practice, and a clear mental model for every area type that tells you instantly which LSAs are present and which are blocked. LSA Types 1 and 2 Router and Network. LSA Type 1 is the router LSA. Every OSPF router generates exactly one Type 1 LSA describing all of its directly connected links, their states, and their costs. The Type 1 LSA is flooded only within the area in which it originates. It never crosses an area boundary, which is why routers in different areas do not know the detailed topology of each other's areas. They only know the summary information that an ABR derives from those Type 1 LSAs. LSA Type 2 is the network LSA. It is generated only on multi-access networks such as Ethernet segments where a designated router has been elected. The DR generates a single Type 2 LSA on behalf of the entire broadcast segment, listing all routers attached to that segment. Like the Type 1 LSA, the Type 2 LSA is flooded only within its originating area and never crosses an area boundary. On point-to-point links there is no DR election and therefore no Type 2 LSA is generated. Because Type 1 and Type 2 LSAs describe the internal topology, they are present in every area type without exception. There is no OSPF area design where Type 1 and Type 2 are blocked, because without them routers within the area could not build the local SPF tree needed for intra-area routing. LSA Types 5 and 7 External and NSSA External. LSA Type 5 is the AS External LSA. It is generated by the ASBR and flooded throughout the entire OSPF domain, with the exception of stub areas and NSSA areas, which explicitly block it. Each Type 5 LSA describes a single external prefix, its metric, and the metric type. Type E1 external routes add the internal OSPF cost to reach the ASBR to the external metric, so the cost grows as the route propagates. Type E2 external routes preserve only the external metric regardless of how far the ASBR is, which is the default behavior when redistributing into OSPF. LSA Type 7 is the NSSA External LSA. It exists specifically to solve a problem. Stub areas block Type 5 LSAs, but some stub areas have their own ASBR that needs to import external routes. NSSA was created to allow this. When an ASBR is inside an NSSA, it generates Type 7 LSAs instead of Type 5 LSAs. Type 7 LSAs are flooded only within the NSSA. When they reach the ABR connecting the NSSA to the backbone, the ABR converts each Type 7 LSA into a Type 5 LSA and floods it into the rest of the OSPF domain. This conversion is called Type 7 to Type 5 translation. The distinction between Type 5 and Type 7 is purely one of scope and area type. Both describe external prefixes. The difference is that Type 7 travels only inside an NSSA while Type 5 travels everywhere else. In a totally NSSA, even Type 3 LSAs are blocked, and the ABR injects a single Type 3 default route to cover all inter-area and external destinations. Backbone and standard areas. All 5 thrive. The backbone area, Area 0, and any standard non-backbone area except all 5 core LSA types without restriction. Type 1. Router LSAs describe the internal topology of routers within the area. Type 2 network LSAs describe multi-access segments with ADR. Type 3 summary LSAs bring in inter-area reachability from other areas through ABRs. Type 4 ASBR summary LSAs identify the location of any ASBR in the OSPF domain. And Type 5 external LSAs carry the actual external prefixes redistributed by that ASBR. The memory hook for backbone and standard areas is all 5 thrive. All 5 LSA types are present and active. There are no restrictions, no filters, no blocking. Any router in a standard area has full visibility into inter-area routes and external routes through the complete set of LSA types. It is important to note that Type 1 and Type 2 LSAs are always area local. Even in a backbone area, a Type 1 LSA generated inside Area 0 does not travel into Area 1. The ABR converts the topology information into Type 3 summary LSAs when crossing area boundaries. What all 5 thrive means is that all 5 types can exist within a standard area, not that all types cross all boundaries freely. Totally stubby area 2's the limit. A totally stubby area is a Cisco proprietary extension of the stub area concept. It goes one step further by also blocking Type 3 summary LSAs in addition to Type 4 and Type 5. The only LSA types present inside a totally stubby area are Type 1 and Type 2, which are the area local topology LSAs that cannot be blocked without breaking OSPF entirely. Everything else is filtered out by the ABR. With Type 3 LSAs also blocked, routers inside a totally stubby area have no knowledge of any other OSPF area's subnets. Their routing table is extremely lean. The ABR injects one single Type 3 LSA representing the default route quad 0/0, and routers use that for everything outside their local area, whether the destination is in another OSPF area or an external network entirely. This produces the smallest possible LSDB and routing table, which is ideal for remote branch offices with a single uplink. The memory hook for totally stubby areas is 2's the limit. Only Type 1 and Type 2 survive inside the area. The number 2 is the limit. Only the ABR needs to be configured with the no summary keyword in addition to the stub configuration. Internal routers only need the stub area configuration and will automatically receive only Type 1, Type 2, and the single default Type 3 from the ABR. This is a Cisco proprietary feature, so other vendors may implement it differently or not at all. Network Service Selection Agent and Totally Network Service Selection Agent, normal plus 7 and 2 and 7. The NSSA, or not so stubby area, was created to solve a specific problem. What happens when a stub area needs its own ASBR? A pure stub area would block the external LSAs that ASBR needs to advertise. NSSA resolves this by allowing external routes to enter through a special Type 7 LSA instead of a Type 5. Type 4 and Type 5 LSAs are still blocked at the ABR, but Type 7 is allowed to exist and flow within the NSSA. The ABR then translates Type 7 into Type 5 when forwarding the external routes toward the backbone, making them visible to the rest of the OSPF domain as standard external routes. The LSAs present in an NSSA are Type 1, Type 2, Type 3, and Type 7. The memory hook for NSSA is normal plus 7. It behaves like a normal stub area with Types 1, 2, and 3, but adds Type 7 as the mechanism for importing external routes. The word normal represents the stub baseline of Types 1, 2, and 3, and 7 represents the NSSA specific addition. The totally NSSA combines the totally stubby restriction with the NSSA external capability. It blocks Type 3, Type 4, and Type 5 just like a totally stubby area, but it allows Type 7 for external route import within the area. The LSA types present are Type 1, Type 2, and Type 7 only. The ABR injects a default route as a Type 3 LSA for all other destinations. The memory hook for totally NSSA is 2 and 7. Types 1 and 2 for local topology, plus Type 7 for local external import. That is the complete set.